Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X published on January 5th, 2026, about 6 days ago. It introduces a new method that enables truly infinite horizon streaming for 3D geometry by using a diversity-aware rolling memory to prevent the catastrophic drift seen in previous models. The paper is titled InfiniteVGGT, Visual Geometry Grounded Transformer for Endless Streams. And as we'll see later, the results on their new long 3D benchmark are really impressive, showing stable reconstruction over 10,000 frames. And for those interested in the implementation, the authors have shared their code on GitHub. Alright, Figure 1 sets the stage by comparing this new architecture against 3 existing paradigms. Panel A shows offline models, which process all frames simultaneously but cannot handle live streams. Next, Panel B depicts online methods using hidden states, where the graph reveals that errors accumulate rapidly over time. Panel C then illustrates unbounded memory approaches, which cache everything until they crash from memory exhaustion. Finally, Panel D presents the solution, InfiniteVGGT, which uses a smart rolling memory to keep resource usage stable and accuracy high. Well, the core challenge is deciding exactly what to keep in that rolling memory. Figure 2 investigates whether attention scores are a good signal for this. On the left, the attention maps confirm that adjacent frames have nearly identical distributions, suggesting huge redundancy. Similarly, the PCA embeddings on the right show distinct clustering in the feature space. But here is the problem. Computing these attention maps explicitly is too slow for real-time systems, which forces the authors to find a faster proxy. So Figure 3 presents the complete InfiniteVGGT architecture that implements this solution. The diagram flows from left to right, taking the streaming video frames and passing them through the image encoders. The critical component is detailed in the bottom central panel, labeled Layerhead-wise Rolling Memory. In this block, the model calculates diversity scores for new tokens by comparing them to an expected mean, so it can identify which features are truly unique. It then retains only the top K most informative tokens, while pruning the redundant ones, which keeps memory usage bounded. Crucially, the anchor column of blue squares shows that the first frame is permanently locked, ensuring the global coordinate system never drifts. Okay, Table 1 validates this efficiency on the 7 scenes and NRGBD datasets. Notice the rows for versus GGT and stream versus GGT. They are filled with OOM entries, meaning these models crash from memory exhaustion even at just 300 frames. In stark contrast, InfiniteVGGT, appearing at the bottom of each block, handles these lengths effortlessly. It also surpasses robust baselines, like TTT3R, achieving superior accuracy and normal consistency scores across the board. Moving to the ultimate stress test, Table 2 reports performance on the author's new long 3D benchmark. The scene column reveals the scale of this challenge, with inputs ranging from roughly 2,000 frames in the classroom up to nearly 10,000 for the academic building. While competitors like CUT3R and TTT3R see their error rates climb on these marathon sequences, InfiniteVGGT stays robust. In the bottom rows, it secures the best scores for accuracy and normal consistency, confirming it successfully limits drift over long periods. While the tables showed final numbers, Figure 6 visualizes stability over time on the NRGBD dataset. The solid lines track chamfer distance, where a rise means increasing error. Notice how the solid green curve for CUT3R shoots upward, indicating catastrophic drift as frames are added. In contrast, the solid orange line for InfiniteVGGT stays flat at the bottom. The graph also shows the gray line cutting off early, which confirms that offline models simply cannot scale to these lengths. Wrapping up, InfiniteVGGT makes a compelling case for using diversity-aware pruning to enable truly infinite streaming. By intelligently discarding redundant data, it solves the stability-scalability trade-off that has plagued long-term 3D perception. This represents a significant step forward for embodied AI systems that need to operate continuously. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.